Now, we've been learning about this whole idea of arrangements. And so when we're arranging things, we now know that there's like certain restrictions we can place, right? For example, when we have a race of people, if I wanted to know how many people could just get into the first place, for example, right? It's just how many people there are. Let's say there are 30 people. So the number of ways you can do the first place, there's 30. What if I want to add more sort of people in? What if I want to add more positions? Right, so second and then third. What did I say that I have to sort of consider now with these arrangements? If I want to know how many ways I can, put.
29.
Yeah, right, because 29, why is that, Gemma?
Because you took away one from the first one.
Good, you take away one from the first one, and then the same thing I would do with third. You can take them away, and then you can keep doing this, right? And I said there's no real kind of formula in terms of developing this, and there's not necessarily a formula, so to speak, in your usual sense of like Pythagoras' theorem and that kind of thing, or quadratic formula. But we have a notation to represent this. This sort of situation is what we call a permutation. It's a permutation because you're selecting, now I've used some sort of variables here, we're making R selections from n objects, right? So I'll say that again, R selections from n objects. What are the objects? Well, they're people, right? They don't have to be people, they can be anything. You can be selecting from anything. It could be like numbers, it can be letters, and they come up with all sorts of situations. Often they use people because in these situations, there's also a particular order, right? So the positions matter. First, second, third, that's an order, as opposed to what if you were just selecting people for like a cricket team that people are going on. It doesn't matter what order you select them, they're all going to be on the team, okay? So that's a different type of arrangement. In permutations, the positions or the order matters, we say. So the order matters, or the position matters, either one, however you want to think about it. The order / position matters. And so when we're thinking about this formula here, what's actually going on, right? It's not 30 factorial because you're not going all the way down to 30 times 29 times 28 times all the way down, right? How far are we actually going down to in terms of if we were to develop a formula for this NPR thing? If you think about it, let's say we take our, well, it's not 30 factorial, it's n factorial. And what they do is they divide by a certain expression here on the denominator. So think about in this case, right? If we were to take 30 factorial, and remembering what does 30 factorial actually mean again? 30 factorial is just
times like 29.
Yeah, right? Where are we going down until?
1.
Yeah, all the way down to 1, yeah? But in our situation, we don't want 30 factorial. Where do we want to go down to? What value do we want to go down to? 28 in this case, right? And why is that? Because we're only interested in 3 people, in 3 selections. Would you agree? That's your R value, so to speak. And so really what you're doing is you're doing 30 factorial divided by 30 minus 3 factorial. And we'll see why in a second, because what is 30 minus 3? That's 27 times 26, 5, all the way down to 3 times 2 times 1. And actually, this is still just a number that you can simplify, because what happens with these are all on the numerator, these are all on the denominator. And so what you get left with is just 30 times 29 times 28. And so they use this notation here. To say, all right, well, if this is n factorial, what do you think would go on my denominator then?
N minus R.
That's it, Blake, yeah. N minus R all factorial. Can you jot that down for me?
The people.
The P, so that is just kind of like our symbol to represent a permutation. That's our symbol to represent a permutation. We've come up with this notation to sort of represent that. So I'll just explain this again, right? N objects, so these are the total things that I'm choosing from. N minus R, I'm taking the number of objects, I'm taking away how many selections I'm making, and that calculation will give me sort of my answer to this situation, right? It's kind of a quicker way to do something like this. For example, if you had to make more selections, what if you had to make 10 selections, for example? You don't have to do 30 times 29 times 28 all the way down. What could I just put in instead? I could just do 30p10. Now, the question is, how do you actually get 30p10? Well, on your calculators, you have a magical little button. Let me show you. Can you find a button that looks something like this symbol? Anywhere. Have a bit of a hunt. Above times, and then multiply. And so you notice it's in yellow, so what does that mean?
Shift.
You got to use shift. Now, what happens when you press shift multiplication? It just comes up with that P, that permutation symbol. That's what that is. And you can see the way that yellow there, that gives you a clue how to use it, NPR. Well, we need to do, for example, let's just check this actually works. So 30p3, it's a pretty big number, 24,360. If I was to do 30 times 29 times 28, that should give me the same number, and it does. And we can do the same thing with the one I said before, 30p10. Right, and you can see the numbers get bigger and bigger and bigger as you sort of keep doing this, right? As a sort of kind of thinking, right, just to explore the permutation notation and just to think about it logically, without calculating it, what would 30p1 be, do you think? 30, right? Because it's just 30 people, and how many, if you're just picking one of them, you can only get 30. So there's some sort of intuition with this as well. Like, it's not just a black box formula that we don't know how it works, right? So what I'm going to get you to do, I'm just going to get you to calculate a few different permutations for me. So you want to jot these down. This marker doesn't work. Let's put in our, now you just use your calculator for these, but just so that it's clear what's going on here, I'll still just write out this in the factorial notation, so you understand that this is actually the same as, and this will be helpful later on, 6 minus 2 factorial should be, and because sometimes you have to write it out in this notation in order to answer some of the problems, right? So can you put in that Oscar for me? What did you get?
The first one.
Yeah.
30.
30, because that's just 6 times 5, because the 4 factorials will cancel those other ones out, as you can see. And it doesn't matter how big these numbers get, we can always calculate them out, right? Kaylin, AP5, did you get that one? Yeah? What did you get for that?
6,720.
We got something else? No? 6,720?
No.
No, different answer? Yeah, and last one?
60.
So, yep, 60. So, how would I write this one now? That's 5 minus 3 factorial. And yep, we'll get 60. Perfect. All right. So, we can just use our calculator to do this, and the whole goal of them in the end is to actually apply them to these kind of situations. So, for example, we've got a few here. How many different arrangements can be made? So when we were looking at these, remember the whole idea is that our formula, NPR, tells me that I have this many objects, and I'm selecting, these are how many selections I'm making, right? These are how many selections I'm making. So just sort of look at the problem and think about, okay, how many do you have and how many am I choosing from? And most importantly, does the order matter? So the way in which you arrange them. Anytime you have some sort of line or row or positions, for example, like first, second, third, that's where these are going to matter, and these all meet that criteria. So over here, I'm thinking, all right, well, what's my N and R? I'm choosing from 9 things. So that would be 9p, and I want 6 paintings. So that'd be 9p6 is my R value. And do you want to calculate that for me, Sophie? Tell me what you get.
60,480.
60,480, right? So there's an astoundingly large number of ways. We've only got 9 different things, and we're picking 6 of them. And there's a huge amount of ways in which we can arrange them. And last one for me, Blake, 10p5 for this one. So you've got 10 people and 5 are chosen.
30,240.
30,240, perfect. Questions on that one? All right, jot that down.